I want to briefly talk about the chemicals that we're going to use in today's experiment. The first one is granular zinc. Granular zinc looks like a metal, except that it's ground relatively fine in order to accelerate the rate of the reaction. There are no safety concerns with this particular chemical. The next compound is iodine, I2. Iodine is a group 7 element, and like all group 7 elements, it's really reactive. This reactivity is what makes it particularly dangerous. It's a solid, dark gray, shiny compound, very brittle in nature. It also has the tendency to turn into a purple gas at room temperature. When you breathe in this gas, your lungs start to burn immediately, and very quickly you'll develop pulmonary edema and die. So it's definitely something you want to be careful with. Even small doses of exposure to iodine over the long term can cause other issues, such as thyroid disease. So again, be really careful when working with iodine in the lab. The last compound that I want to talk about is methanol. We're going to be running our zinc iodide synthesis in a methanol solution. Methanol is a clear, colorless liquid. The primary concern when using methanol is its high flammability. It vaporizes very quickly, and both the vapor and the liquid form can catch on fire. Secondly, methanol is toxic. So while I would expect no one to drink this in the lab, that goes without saying, we also have to be aware of inadvertent forms of exposure, such as breathing in the vapor. This can lead to blindness and liver damage, so we definitely want to avoid breathing in methanol vapor. Therefore, to protect ourselves, to protect the lab, we're going to run the methanol synthesis in the hood. All right, so now I'm going to decant the liquid methanol into the beaker. I'm going to rinse that with a little bit of additional methanol. And then I'm decanting that rinse portion of methanol into the beaker as well. So now this should just be the unreacted solid zinc. And in here is my soluble, it's soluble in the methanol solution, the zinc iodide product that we just produced. Looking back on the prior clip, I realized that I was blocking the decanting process with my hand. So I'm gonna rinse the zinc one more time and decant one more time, just so I can better explain what decanting is. So when somebody decants, what you're doing is you're carefully pouring off the top layer. In this case, it's a liquid layer, and we're trying to leave the solid behind. Sometimes you can decant a liquid off of a liquid layer, like you can imagine decanting a top layer of oil off of some water. So I'm carefully pouring the liquid out, making sure that none of the solid comes out of the beaker. What happens? There's gonna be a little bit of methanol left. If I try to get all the methanol out, I'm gonna wind up pouring out some zinc as well. And that's why we have to do the rinse steps, with the idea that there's always gonna be a little bit of methanol left behind. That's fine. But we're gonna do our best to transfer the zinc iodide to the other vessel. Now that the flask and the beaker have had an opportunity to cool, I'm gonna obtain their masses. So first, the Erlenmeyer flask that has our solid zinc in it. Alrighty. I'm gonna switch this out. Tear it again. Next will be the zinc iodide product in the beaker. Alrighty, and then you'll record that value.